just as a start, Simon Foster, would you like to, Dr. Simon Foster, great to introduce you. Would you mind telling us who you are and what your job title is?
I'm Dr. Simon Foster. I'm a solar terrestrial physicist sometimes at Imperial College. So that means my area is looking at variations in the sun's energy and how that affects the Earth's climate. I'm the engagement lead for the Space Lab at Imperial College, and I'm the physics outreach officer for the physics department at Imperial College London.
Oh, wow. Thank you. And you said you're a solar physicist. So what does your typical day look like? What do you do every day?
Well, starting off, it's checking emails, which I think is everyone's kind of thing, seeing if there's anything urgent that needs to be done or anything that can't be. A lot of it, apart from that, is planning out. I am kind of at a computer most days, and kind of, I think for nearly all scientists in various different ways, well, unless you work in a lab, but modeling, kind of writing stuff, a good computer is kind of key to it. So I am at my computer most of the day. Sometimes I'm reading papers, reading reports, papers, I mean scientific papers, seeing if anything's come out. That's changed a lot, but there'll be more of that later. But kind of a lot of it is planning time out and then actually doing stuff, trying to write to people I'm collaborating with, talking with them, actually seeing how we can move projects along. It's quite varied, actually. I'm trying to say the only continual thing is being on my computer. But I think it's trying to move projects along, get things done, come up with ideas. A lot of it is collaborative work, but I suppose there's no real, apart from my email and checking that, which is my routine, there's no really typical day. Because I've got a lot of different jobs and a lot of different hats. I kind of try and balance a lot of different things.
Okay, thank you. So following on with that, as a scientist, what would you say is one of the biggest misconceptions of your job? When people think of a scientist, how is that most different to what you do?
Oof. I think there's several ones. I think most people think that if you're a scientist, somehow you're this genius. And I think one thing I've proved throughout my career and in my life that I'm not. And so hopefully I've dispelled that myth that scientists are somehow kind of others and we're not like everyone else in society. We are, okay? We're not kind of these peculiar people with oversized brains that can't communicate or engage with anyone else. You know, the typical scientist, you know, like the lab coat, glasses, strange hair, kind of, male. Well, I suppose I am. But apart from that, you know, this general idea. I like football. I like music. I like all sorts of. So I'm very, very much a normal person. So that's a misconception. The other misconception is, and I think this is something I always try and talk to children about, is that I think we get this again. A lot of the idea of how a scientist is portrayed is that we're either in a lab blowing things up, we're either with a telescope. You know, from me being a solar physicist, all I do is look at the sun all day on the computer, don't look at the sun directly, but we're just sitting there doing these wonderful things and sitting around drinking coffee and just talk. It is actually a really hard job. It's stressful. As I say, we spend a lot of time reading emails, replying to people, writing out things in meetings. So in some ways, it's just like a normal office job. However, I should say the caveat is that unlike a normal office job, and I've got friends who work in finance and things like that, the great thing about science is that very occasionally you get to find out something that no one else has seen before or found out before. You are the first person to see that. And I would say that that's the payoff. In that, yes, it is for a lot of people, it's a normal office job, which sounds peculiar, but it is. We've all got offices. We work in offices, most of us, or labs, but you know, and most people got an office. But you have the payoff of you are working in something that's truly exciting. But I don't want to. Yeah, there's that misconception that all we do all day is wonderful things and come up with. We invent big robots and things like that. There's a lot of disappointment. There's a lot of hard work. There's a lot of dead ends. There's a lot of grinding to get to that point. So I think, and I think we should be aware of that, because actually, I don't want people to go into science thinking, oh, I'll just get to sit around a lab doing stuff, whatever I want all day. We are trying to move to somewhere, but as I say, the payoff is that you will do amazing things. So,
okay, thank you. That's a really, really good answer. That describes it very well, I think. So you've kind of already described this, but what would you say are the worst and the best parts of your job?
So the worst part is being stuck at my computer all day. And that is, emails coming in, and that I think is sometimes you have to do a lot of kind of, how could I put it, grinding. You have to, kind of get through them up, which every job has, but you have to do the emails. You have to do things that you don't want to do, spend a lot of time writing reports and things like that, which is not where my skill is. Some people have that skill, I don't. So that's where the worst part. The best part is that very occasionally, and some people do it more, I would say it's, for me, it's very occasionally, but you get to see something that no one else has seen before. You are the first person to get your hands on that data. You are the first person to see an image, maybe of, I don't know, a distant galaxy, of a sunspot, of a flare, something like that. And that is amazing. So that is the payoff. You do have to wade through a lot of mud, but the payoff is, and I think that's what keeps everyone going, and that's the joy of science, is that you see something for the first time. Again, we're in the middle of the COVID crisis. Hopefully when this goes out, we're finished, but that will be finished because people would have invented vaccines, would have invented tests. Someone would have sat there in a lab and gone through an awful lot of mistakes, things that went wrong, didn't go right. And that's really important to say. Scientists never get it right the first time, unless you're incredibly lucky. We all have theories and then it doesn't quite portray out. And biologists and life scientists, medics would have gone through all this wrong, everything going wrong, and then they would have got it right finally. And that would have been an amazing payoff for those people. So hopefully, someone there sat in a lab and gone, oh my God, I think I've got the vaccine. And they would have been, that would have been like, I don't know, winning an Oscar, scoring a goal in the World Cup. They would have sat there and they would have been an amazing buzz. And that's what we get. So that is the payoff.
Wow. Thanks. Again, fantastic answer. Wonderful. Thank you. Hearing you talk about science, you sound extremely passionate about it. So I wonder, have you always wanted to be a scientist, or was this something that you didn't know was an option and you came into?
I actually, ever since I was a little boy, wanted to be a footballer. So that was my joy. So I loved football. I absolutely love football. I pretty much grew up, so I'm an Arsenal fan. I pretty much grew up at Highbury Stadium because all my family worked there. So I used to just be able to, it was a dream looking back. I didn't realize how fortunate I was. I used to just be able to walk straight in. I knew the players. I just played football all the time. I just absolutely lived, breathed football. It's what I wanted to do. Now, obviously, that is down to a lot of hard work. I've got problems with my knees, so I've got arthritis, which doesn't make you set up for football. The other problem was I wasn't particularly good. And I think, I think some people are just, I wouldn't say gifted, but I wasn't. I love it. So I love playing football. I love watching football. It's something that I really enjoy. And then actually, I got into science at secondary school. And I did very little primary school. Pretty much no science. And I had I had an interest in it because occasionally I'd get books. And I had I was given a second-hand book about space and astronomy, and there was a picture, and I was only about 4 or 5. There was a swirling picture, and it was depicting, I think it was a galaxy forming, or something like that. And I remember that really sparked my imagination. And I was always interested. I used to build machines out of cardboard boxes and things like that as a kid. But we didn't really do any at school. And then at secondary school, I actually started to do science inside science labs and things like that. And luckily, I had a really good teacher. Actually, all my teachers were really good, but one of them, Dr.Simon, was a physicist. And he kind of said, you know, maybe this is something you should kind of explore. And so that was something that sparked my curiosity. And so he kind of, I think you get guided by people, and he guided me down. And he was always talking about rockets and space, and I thought he was an astronomer. Actually, he was a atomic physicist, but he just loved space as well. So he kind of pushed, I wouldn't say pushed me, but guided me down that route. I kind of had an interest in it anyway. And he just kind of amplified that interest. And when it came to my A-levels, I picked physics, chemistry, maths. And I kind of thought maybe I'd like to do space science at university. And that's what I did, luckily.
Oh, fantastic. So, because my next question was going to be, was there a particular event or person that made you want to work in STEM? But it sounds like you've just answered that.
No, there is another person, so I was keeping that in mind. So I can. So there was someone else who kind of acted an inspiration. Now they weren't in my life, but I saw them, and that was an astronaut called Helen Sharman. Now, so she was Britain's first astronaut. So I keep having to plug on about this because everyone thinks it's Tim Peake, and it's Helen Sharman. So Helen Sharman went, I think, up in the early 90s or late 80s. I was a little boy at the time. And she actually really piqued my curiosity. So she was one of the reasons, again, as a little boy, I sat there thinking about it, thinking to myself, actually, maybe I could... this is something I'd like to go into. So I remember her going up on the Mir instrument, and that really captured my imagination. And so I kind of thought to myself, I wonder if, my other option was actually I'd always wanted to be an astronaut. So I thought to myself that I'd like to be an astronaut. Now, that didn't quite come off for a million and one different reasons. But again, seeing her go up, I do think there is something in the kind of the inspiration of seeing someone do something. I don't know, just because there have been no British astronauts up until that point, and she was the first. And actually, even though I was a boy, she's a lady, it didn't make any difference. It was just that kind of thing of seeing someone do it from my country, and she was very normal. Now, again, so I suppose that was one of the reasons why I was interested in space science, seeing her go up on a rocket and go to Mir and things like that. The amazing thing is, I actually work with her now and know her quite well.
Wow.
And so, so I say she was my hero. She was my inspiration. So she was one of my heroes. I had two heroes growing up in kind of job-wise. One was a footballer called David Rocastle, who I was lucky enough to know. And I know my second hero, Helen Sharman. And they were both amazing people, great people. And I worked with her. And all I could do the first couple of times I was in meetings and I sat next to her I think I just said to her, she used to whisper silly things like, well, it sounds a bit weird, but I remember I kind of introduced myself and I just went, "You're my hero." And it took me about 5 meetings of being in the same room where I could get over just pointing out to her how great she was. We now talk normally, but she was an inspiration. And I want her to be an inspiration to lots of young boys and girls in this country, because a lot of people don't know who she is. They know about Tim Peake and know about other people, but everyone should know about Helen Sharman. Sorry, I'm fanboying there.
No, fantastic. That's incredible that you, your two biggest heroes growing up, that you got to meet both of them and you work with them.
And they knew my name. Poor David Rocastle sadly passed away. I knew him as a kid, and I remember him saying, "Oh, hello, Simon," and I melted. And it's the same with Helen. She was like, "Hello, Simon," and she kind of introduced me to people, and I was just like, "Oh my god!" So sorry, rambling on.
Fantastic. No, that's terrific. So building off that, if you were currently a kid in like primary or secondary school, and you started hearing about science, technology, engineering, and maths, and you thought this is pretty cool, what do you think would be some of the most important things you could do at that age to kind of try get involved in these activities?
One of the easiest ways, I should say, to get involved in STEM or STEAM, if you include in arts activities, is to actually, there's loads and loads and loads of opportunities at school. Make use of them. Okay, so every school I've been to, there are passionate teachers there. So make use of those passionate teachers. Ask them if there's anything that you can do that goes beyond what you're learning in the classroom. Teachers are always being bombarded, because I'm bombarding them with activities that they could do, competitions, schemes, whatever, that they could take part, that we want their students to take part in, because we in a university are desperate to try and infuse more people into becoming scientists. So I would say make use of that. That's the easiest thing. We all go to school. We all have science lessons. Make use of that there. That's the easiest thing you can do, because it basically requires the least amount of effort on your part. You don't have to trawl around on the internet. You don't have to go around. You've got brilliant science teachers there. Make use of them. Make use of the labs you've got there. You've got, you know, I doubt very much a science teacher, because I have been a science teacher and I've had students come and I've been overjoyed that I can get them doing other stuff with them, doing silly things, you know, exciting things outside of the curriculum, because that's quite boring. So make use of that. The other thing is look online. There's always competitions. There's always things like schemes like NASA, the European Space Agency. Sorry, I'm being very spacey here, but the UK Space Agency, Royal Astronomical Society. I'm just trying to think. All these different space groups in the UK will have things. If you've got access to the internet, and hopefully you have it at school, go online, look at those groups and see if they've got any competitions, any kind of activities that you can take part in. Other good thing is go on YouTube and look at science talks. There's loads of, it's amazing, you know, tons and tons and tons of resources on YouTube. So even if you haven't got internet at home, because I remember I didn't, because, well, I'm sounding old now, but when I was at school, the internet was relatively new. We had a couple of computers and it took forever to download stuff. Literally, even a web page, you couldn't go back and forth. You know, you had to wait 5 minutes for it to come. Oh God, I sound like I'm ancient, but that was last.
No, it's not that long ago.
Millennia. That was several decades ago. That was last century. But even if you don't have the internet at home, make use of it at school. It's free. You can get it there. Most schools have high-speed internet. Make use of it there. So make use of all the resources you have at school. That's the best and easiest thing you will have.
Fantastic. Great. So talking about like how things are changing, you said the internet before, but as your time as a solar physicist, as a scientist that looks at the sun, how have you seen your field change? Have you seen a change at all? Is it still changing, or is it being kind of the same?
I think the biggest change actually happened when I first started. So when I first started in science, it was when we first started to get hold of what you could classify, a lot of people now in science call it big data. And that is huge, huge reams of data. So we had data from the sun, observations of the sun that people have made with special equipment, I've got to say that, but going back hundreds of years. But it was all in massive books. Like I got hold of one of them, and it was from the Greenwich Observatory. So in London, there's the observatory, and there was sunspot, and these books are like that, full of numbers. Now that is indigestible. You know, people would go through them, and there wasn't much you could do with it. So much so that actually the observatory got shut in the 1980s because they were just like, well, it's generating all this data. Sunspots go up, sunspots go down. You know, do we really care? There were other. So anyway, when I started my PhD 20 years ago, God, they'd actually digitized all this data. So they'd taken all these books, and some poor people You can look the story up. There's a lot of urban myths how they did, but someone, basically hundreds of people, gone through this data and typed it into a computer. And we now had it you could download from the internet. So that was the other thing. The internet was now a lot faster. And that changed while I was at university, that you could download stuff really super quick. So we had all this data. So instead of it being in books that you could fill a room with, you could now get it on a file that you could download in seconds. Amazing. So you could now transfer data. You could send data, huge books of data, via email, anywhere all over the world. The other big step was, and as I say, this happened again while I was doing my PhD, is computing power has just gone up massively. So I had a big old, it was called a Sun, a Linux, and apparently, it cost thousands. Of pounds. So I didn't appreciate it at the time. I was, so I didn't have a PC. I had this Sun, Linux, whatever it was, and I used MATLAB on that. And I could actually, thanks to the computing power on this computer, which now looks rubbish, at the time was cutting edge, I could process these hundreds of books in seconds and look at all the secrets. And this is what I was saying earlier about all these, you're seeing it for the first time. And this is what I didn't appreciate with my supervisor. He'd got a hold of all this data and hadn't realized what to do with it. So he developed a PhD around it. And I could see all this stuff about sunspots and changes on the surface of the sun going back hundreds of years, and no one had seen it. And I was just churning out all this data. So the ability to actually, one of the big thing is this big data, which you'll hear a lot of, the ability to actually process hundreds of years of data in seconds and look at trends, look at changes, computing power. I'm on a tiny laptop at the moment. It's literally wafer thin. I sound sorry. It's ridiculously thin. I keep looking at it. I don't. Half of it's a screen, half of it's a keyboard. Where is it doing all the computing in it? This thing is hundreds of times more powerful than this big, huge box I had, and that was 20 years ago. This laptop here can do, in seconds, again, what it was, again, the same computer. Computing power has gone up massively. And that is when so, you can make models do stuff far quicker now than you ever could. Communications improved. Again, like how we're talking now, I used to email people. I used to write letters to people. Because they did I shouldn't say old people. There's some old, researchers in their 70s, 80s that retired, weren't at an institution anymore, didn't have an email address, but I got their physical address. I'd write letters to them to get, now everyone's got an email address. I'd write letters to people because, they'd done stuff in the 1950s and I'd read their paper. And it was relevant now. And it was just, I remember I had a lovely correspondence with a guy in Germany. And he was he ended up just going, look, I did this. It was in the 1980s he'd done stuff. He was I've forgotten most of it. I had all these questions about his paper. And he was like, to be honest, in 30, 40 years, I've forgotten it. It didn't go anywhere. But now it was relevant again, weirdly. So the internet actually, again, is the way you can now dig up stuff. You would have to, Google was just starting when I was at uni, or I became aware of it. But now you can research stuff and find stuff in seconds that, you would have, my friends, a lot of musicians saying digging around in the crates, going to music stores and you'd have to pull out records, and now you can just go on Spotify or Deezer. It's the same with science. You'd have to go through tons and tons of papers, but now you don't have to worry about it. Google, it's just accelerated. So everything's faster now, everything's smoother, and that's brilliant. Everything's more collaborative, I would say. That was the big difference.
Wow, that does sound like a huge difference. So going ahead, I know people are notoriously bad at this in general. I mean, we all are, because it's very difficult to do. But if you had to guess, how do you think it's going to change in the next 10 or 15 years or so?
Wow.
That's a tricky question.
God, how science will change. Wow. I think it will.
I don't know, because that's probably the answer.
I was going to say, I think it will become a lot more. This is something we were discussing earlier. I think science will become a lot more collaborative. So I think you will see the breaking down of old kind of compartmentalization, old groups. So, there's physics, maths, chemistry. Now, you'll probably still be taught that at school, but when you get to university, you'll probably still have the Department of Physics, the Department of Chemistry, but actually it will be hugely cross-collaborative. It won't be these little silos of science anymore. It will be far more, for example, I'm at Imperial College. You will have far more kind of collaboration across the college. It will just become more like science. I know that sounds weird. And you will have far more collaboration with institutions because it's so much easier. For example, one of the things that people probably don't, just to give you an idea of how collaboration and crossing the paths, a big area of science now is quantum biology. Wow. Now, I know a guy who started that. Now, you think that how can that be so? You've got quantum physics, tiny little particles, waves even, but what the particles that make up the atom, smaller than the atom. And you've got biology. All right, when that's still pretty small when you're talking about molecules and DNA and stuff, but how can that be linked? The guy I know, John Joe McFadden, thought to himself, well, actually, he was a biologist. He said, but are there any quantum effects that could be causing mutations at the DNA level? All you have to do is change one atom, how it behaves, and you've completely changed it. So he actually went and spoke to a quantum physicist. And the quantum physicist was like, your understanding of quantum physics is terrible, but you're on the right line with how actually there may be some impact of quantum effects. That's now that's becoming a huge area of medicine. So I reckon you'll get these weird collaborations. You will start seeing more and more cross collaborations between different areas that you've never seen. And I think that's the huge leap forward. I do think the biggest leap will be in quantum physics. And a lot of people are interested in it. And when I did it at university, it was just theoretical. And you're just like, well, why am I, I did it. And you're just like, it's a lot of maths. I sort of understood it, but to me, I'm always heavier on the application. So with space, I did astronautics, I did space science. I could see it. I could see a rocket. I could see a satellite landing. I could kind of put the numbers into a model in my head and visualize it. With quantum, it was like, well, what's the it's not really putting a probe on Mars. It's not putting a satellite up there. I couldn't see what it did. It was interesting, it was peculiar, but it seemed, frankly, a bit irrelevant, which is terrible to say that. Now, probably quantum tech, I didn't realize that lasers, by the way, I was that ignorant. Lasers are quantum technology and things like that. But quantum technology, we are literally on a revolution. In 10 years, you will have a quantum computer. That quantum computer it will not be faster, it will not be powerful, it will do things that we cannot imagine now.
Wow.
So that will be, these strange quantum technologies will be everywhere, like quantum meteorology, and that is basically sensing gravity. They're putting actually a quantum detector on submarines, so that way it can know how it's moved. So you would do a starting point, and it will know down to like millimeters how far it's moved. So a submarine has to come back up.
Gravitational field so well or something.
Yeah, it's just amazing. And those technologies will be everywhere in 10 years, 15 years. They will be embedded in everything, and they will change things. But as with everything, you don't really know. It just becomes life. So we won't be sitting in 15, 20 years and looking around us going, oh my God, I'm in the future. You'll just be in the future, and it will be, look at this. This is my mobile phone. This is unbelievable, the power of this. Everyone takes these for granted. You take this back 20, 30 years, people will think this came from aliens or something like that. They wouldn't be able to understand. As the screen on it is unbelievable. So, what we take for granted now, that's the issue. There are some technologies coming that will be revolutionary.
Fantastic. Wow. Great. Thank you. That's been terrific. One last question before I let you go. If you had to come up with, just off the top of your head, what's the coolest science fact you can think of?
Oh, wow. Okay, so I will use one from my own. I've got two, actually, if you don't mind. I've just thought of two. So my first one is, because I love it, it is probably maybe not that cool, but the average sunspot, because I love sunspots, is the same size as the Earth. So the Earth is that big that a sunspot, which is insignificant for the sun, is bigger than the Earth. Now, here's another really interesting one. So when you always think of the aurora, you think of the aurora happening at the North and South Pole, the cusps. You get the aurora, or aurora australis in the south, and aurora borealis, I should know, in the north. Okay. Now, if you get a solar storm big enough, and this is a huge, it's like an explosion on the sun's surface. It hits the Earth's magnetic field, and the material gets fed around the Earth to the poles. Okay. If you can get, and this has happened, and it's happened recently because I've got photographic evidence of it from one of my students. If you can get a solar storm big enough, it can actually make the aurora move from the poles all the way down to the equator, and the aurora has been seen in the Caribbean. And one of my students is from Trinidad, and last summer he sent me a picture from his uncle had taken at night, and the aurora was happening in Trinidad, and it's been seen in Jamaica again before. And I've seen the aurora in London and in Bath before.
That's incredible.
So with a big enough solar storm, you don't have to go to the North or South Pole. You can see it in Britain. You could even see it in the Caribbean.
That's incredible. They're two very good facts. One last thing I have to ask you. Yeah. Is it true that a duck's quack doesn't echo?
A duck's quack does echo. We found that out. A guy I know, actually, I'm going to work with him weirdly on some sound stuff. I think it's Trevor Cox is his name. He said, I don't know, it was an urban myth, but unfortunately we did a TV show with that title and it was false. So yeah, we were kind of starting and we're going, but they do echo. And yeah, so that didn't bode well, although we did do.
But we wouldn't know unless somebody went and tried it out like you did.
Yes, put a duck in a cave, or at least a recording. But I think this guy Trevor Cox, Professor Trevor Cox, is at Manchester. I think he actually did that. I think he got a recording. And I think there's something called the Ig Nobel Prize, where it's just the stupidest thing. I think he was nominated. I don't know if he won, but there's I know a couple of people. A guy I work with, Piers, I think his name is, in the physics department, won an Ig Nobel or was nominated. I know several people, but it's for really pointless, stupid science. But occasionally it's worth doing.
But still good science, right?
Yes, yeah. Yeah, well, on that note, actually, on something interesting, the guys that invented graphene, you may have heard of that, which is this amazing carbon, like you've heard of like carbon fibers. The guys who invented that actually did it by taking a pencil, rubbing it on paper, and using sellotape to get one layer of graphite off. And they were doing it messing around in the lab, thinking, how could we do it? And it turned into like a multi-billion-pound industry that won them the Nobel Prize. Wow. So messing around occasionally, doing something really simple, really easy, does work.
Wow, that's really cool. Great. Thank you so much for your time, Dr. Simon Foster. Thoroughly enjoyed it. Really enjoyed it. And thank you so much.
Thank you very much, Alex. Thanks, Stem the Violence.